Hello, I'm Aaron and welcome to my talk, The Power of Cursed Code, a Tour of Ruby. In this talk we'll be discussing the Ruby programming language, what Ruby code looks like, the features that set it apart, and the ways that these features can influence the code that you write. So, let's get started with the easiest question. What is Ruby? It's an object-oriented scripting language. Ruby is usually interpreted with YARV, yet another Ruby VM being the current official implementation. Other interpreters do exist, such as JRuby implemented on top of the Java virtual machine, so that Ruby and Java code can seamlessly interoperate. Ruby shows inspiration from Smalltalk, as lots of the terminology used by the language's standard library comes from Smalltalk's object-oriented model. What we would call invoking or calling a method in many other languages is referred to as sending a message in Ruby, and checking if an object has a particular method is called checking if an object responds to a particular message. To be honest though, many people, including myself, will just use the standard terminology of invoking or calling when discussing Ruby. There are some ideas from Perl too, such as the very terse syntax and the fact that Ruby code can often be borderline illegible. Compared to other similar languages, Ruby places a surprising amount of focus on metaprogramming. Metaprogramming is essentially working with your code in your code, inspecting your program dynamically at runtime and looking into or adding methods and types. Ruby is also very extensible in that all classes can be added to after their creation, something we'll look at later. There is a web framework built on top of Ruby called Ruby on Rails, or just Rails, and it's one of the primary reasons that Ruby sees use. Rails uses the power and flexibility of Ruby to enable you to write complex, database-backed web apps at blistering speed. Since Rails uses quite a lot of the Ruby features I'm about to highlight, we'll discuss Rails more near the end of the talk. What do I personally like about Ruby? Again, it has a nice concise syntax that I find easy to read and write. The standard library is great, especially for dealing with collections and iterators. I find the tooling to be really good, and new tools coming along like the sorbet type checker mean that it's getting even better. And back to Ruby's core thing, Metaprogramming. Lets you implement features however you want, whether or not that's a good thing to you. Let's take a look at the distinctive features which Ruby has, explained through simple examples of each. We can learn a lot about Ruby by simply looking at a small program written in it. This snippet of code will print the numbers 0, 1, 2, 3, and 4. This works like a count-based for loop in many other languages, except that this isn't some syntactic flow control construct, this is just a method call. Here we are calling the times method on the integer 5. You might be thinking, well, this is a method call, so where are the parentheses? Well, in Ruby, parentheses are optional in method calls. The code that we have here is identical to this code, with the parentheses added. In Ruby, it's common practice to omit the parentheses on methods with no arguments, and on many kernel methods like puts. So let's remove those again. The other important Ruby feature on display here is blocks, which are an elegant way to pass a closure into a method. A closure being basically an unnamed function, which can access local variables. The code between do and end is the block here, with the I in pipes indicating that this closure takes one argument, I. That times method on the integer class invokes the given block, in this case 5 times, with I being 0, then 1, then 2, then 3, then 4, with the puts method printing each value. Even after this very first glimpse of Ruby, we can already look at how such a flexible syntax can let us write very elegant code. Suppose we wanted to create an interface where we can write programs to control a robot with simple commands like move forward 5 steps and turn left. This can be expressed beautifully in Ruby. The optional parentheses make this rather nice to read and write. The interpreter sees this as sequential and nested method calls, So you could make this work to control your robot by implementing methods like move, forwards, and turn. Another interesting part of Ruby's syntax, which is a bit more unusual, is the backtick command syntax. If you write a string but use backticks instead of quotes, it is executed as a command on your system, and the resulting string is the result of that command. Here we've used the Unix ls command to list the files in the current working directory, and get the result as a string from within Ruby. This is a nice feature for scripting, but suppose you wanted to do something else with that syntax. No problem. If you define a method called backtick, you can override what this does. Here I've made backtick into a dedicated shouty string syntax, which will convert the contents to uppercase and append 3 exclamation marks. Inside that method definition, the hash curly braces is string interpolation, basically a fancy way to concatenate strings together. Now, overriding the behaviour of backtick like this is not good practice, and will apparently upset my syntax highlighter as well as all other Ruby programmers. As one last point about the syntax that Ruby gives you, there are some special global variables, most of which start with $, and have a single character name. $0 is the name of the currently executing program. This makes sense, I suppose, especially if you've used bash, where it's the same deal. Now, what do you think $1 to $9 are? I'll give you a moment to think. If you said that command line arguments passed to your program, I wish you were right, but unfortunately you are wrong. $1 to $9 are the first 9 regular expression capture groups from the most recent use of the triple equals operator. Yeah, it's not the clearest choice. The triple equals operator is interesting. It's the, yeah, that's like kind of equal, I guess, operator. It says that a string is equal to a regular expression that it matches, or that an instance is equal to its class. It's strangely defined, but immensely useful. Now, let's start looking into that metaprogramming which Ruby offers. Here is a simple old method definition. We define a method called double, which multiplies the argument by 2 and returns the result. As a side note, we don't use return here. Ruby implicitly returns the last statement of a block. There's no true dynamic element to a definition like this, it's just using the fixed name double which is embedded into the syntax of our program. But Ruby gives you another way to define a method. There is a method called defineMethod, which, given a string for the method name and a block for that method's behaviour, will define that method. Here is a code example where we've defined the same double method as before, but using defineMethod instead. The fact that defineMethod is itself a method with arguments means that we can use this to dynamically define methods with names and functionality determined at runtime. So, Ruby lets us dynamically define methods, but it also lets us dynamically not define methods. There's a special method on every object called methodMissing, which is called if we try to invoke a method which does not exist. Here I've created a class called greet and defined methodMissing as a static method, that's what the self dot means, which constructs a string saying hello, followed by the given method name. So, if we try to call the Aaron method of the greet class, we never actually defined a method called Aaron, so methodMissing handles it and returns the string hello Aaron. This means that in Ruby, you can effectively define a wildcard method. There are many uses for something as powerful as this, most of them being pretty cursed. We'll look at one particularly fine example later. Something else that's unusual compared to other languages is that in Ruby, all classes are open. Methods can be added, replaced, or removed on a Ruby class after its definition. Compared to languages with extension methods, like C# and Kotlin, this is one step further. There's no protection around what your code can do to a class. Plus, those aren't really modifying the class, just offering some syntactic sugar to call static methods on your extension class. Ruby truly modifies the class globally in your interpreter. Doing this is very common. Extensions to the core types can lead to elegant looking code, and some libraries, like Active Support, focus almost exclusively on doing this. For example, Active Support lets you compose dates out of integers with expressions like 3.days.ago, or use a set of inflection rules to pluralize strings. The problem with this, as you might be able to imagine, is that if you have dozens of libraries adding methods to things, you might get clashes or just polluted feeling overcomplicated types. In reality, this isn't too much of a problem, but it is something you need to consider. Refinements were added to try to narrow the scope of class modifications, but you hardly ever see them used. Clearly, Ruby programmers don't like being held back. A quick side note on that pluralization thing. The database component of that Ruby on Rails web framework uses it to create database table names. The inflection rules had a special case to change man to men. Unfortunately, this is a bit too wide a scope, and that is why there are 477 GitHub repositories which have a database table named human. Time for some simple code examples of open classes in action. Here I added a new method to the string class called shout, which uppercases it and adds exclamation marks. It's as easy as this. There's nothing to differentiate creating a new class and adding to an old one syntactically. It's just as easy to replace methods. Here I've banned adding integers together by replacing the functionality of their plus operator. Once again, there's nothing to syntactically differentiate this from defining a new method. You could just replace some important method without realizing and have a very fun time debugging it. Ruby gives you dangerous tools. Be careful with them. One final interesting Ruby feature before we start looking at some real applications of this: block passing. Here is a method definition called withMyName, which captures any block it's called with into that highlighted variable called block. The ampersand differentiates a block argument from a normal argument. If we capture a block like this, we've got ourselves an object which is kind of a blob of code called a proc, as in procedure. Like many things in Ruby, it's still somewhat malleable. We can pass this proc into other methods as their block, combined with the instance exec method, which every object has, which evaluates its block inside the instance. This means that we can change the self context of the block passed to a method. If you use JavaScript, this is like the bind method. At the top level context of a Ruby program, self is a special object called main. As we mentioned earlier, Ruby blocks are closures, and closures can access the scope they're created in. So if we use a block at the top level scope, you would expect that itself is a main, but because we've captured the block and passed it into instance exec on the Aaron string instance, self in the block passed to that method becomes Aaron instead. Right, that was a lot of complicated explanation of some of Ruby's core language features. Now let's take a more light-hearted look at what we can actually do with these. An important disclaimer: the code you are about to see is code that you can write in Ruby. It is not code that you should write in Ruby. If you write anything as extremely cursed as this, an actual Ruby code base with other people, I can assure you that those other people will be very upset. That out of the way, let's look into implementing some code in Ruby to convert a value between currencies. The concept of this idea isn't cursed, and there are plenty of very sensible ways to implement it even in Ruby. But I'm going to go out my way to make this as cursed as possible. Ready? We're going to be pulling the conversion rates from a web service, so I'll need to require the built-in JSON library to parse the responses. Using Ruby's open classes, we'll add our currency conversion methods to the numeric class. I know you're not supposed to treat integers as currency, but it's fine for this demo. Next, our first sign of chaos. We're not just defining one method for conversion, we're defining all the methods to do our conversion. Here I've defined method missing to catch any calls to non-existent methods. If the method called on a numeric instance doesn't exist, we'll check if the method's name matches this horrible regular expression. This regular expression matches 3 lowercase letters, 2, and another 3 lowercase letters in snake case. To simplify all that, we're looking for a call like GBP to USD, where the GBP and USD are the currency codes for pounds and dollars. What all this means is that the code inside this if statement will only execute if we've tried to call a method called one currency conversion to another currency code. In the real world, you'd want to validate that these were actual currency codes. Recall from the beginning that Ruby puts regular expression capture groups into the global variables $1 to $9, so we can extract the 2 currency codes into 2 variables, from and to. Ruby gives us nice convenient shell access with backtick strings, so what's the easiest way to make a web request? Execute curl. We'll use the exchange rates API to find the current exchange rates from our from currency code. This API returns JSON formatted data, so next we pass that JSON and find the exchange rate to our to currency within the data. As the finishing touch, if we don't match that regular expression, so we're not trying to convert currency, call the superclasses method missing instead, which will usually just throw an exception that the method wasn't found. And with that, our wonderful creation is complete. We can take any number and call any currency code to any currency code on it, and it will magically return the converted currency. While this looks flashy, it's very bad code. Really, it's fun to write ridiculous code like this, and not many languages would make it this easy, but nobody would ever want to maintain a code base where there's stuff like this going on. So, with that, we've seen how we can write Ruby. Let's move on to how we should write Ruby. This might be controversial, but in my eyes, the Ruby on Rails web framework is the stellar example of good Ruby. All of Ruby's flexible metaprogramming features shine when you're using them to enable concise code, by hiding magic that takes place in the background. Ruby on Rails is a gigantic web framework. It manages your databases, view rendering, routing between pages, sending and receiving email, real-time communication with WebSockets, rich text editing. All this is just there, ready to use, inside your Rails app. All of this different functionality gets brought together seamlessly by the magical Ruby glue which underpins Rails. One of my favourite parts is sitevic, which lazily loads dependencies when they're needed, automatically ensuring that items are in scope where they need to be. Assuming we've already created a Rails app, let's see the magic in action. Suppose we have a database table for blog posts, and we'd like to create a web interface to browse them. The first step is creating a route to these posts. That is, telling Rails which URLs in your browser should get to which resources. Rails provides a domain-specific language for routing, built up of Ruby methods. This line in your routing table declares that your site has multiple resources which are called posts, and that we should be able to view an index of all posts and show one post. This sets up 2 routes. The first is the /post URL, which invokes the index method on the posts controller, and then shows the posts index view. A Rails controller handles any logic needed for the routes, and a view is a template to create the page shown to the user. The second route created is a /post followed by any number. The number is placed into the controller's parameters under the key ID. Well, okay, we've set up these routes. How do we configure the content? Let's create that posts controller. It's a subclass of application controller so that it can access the page parameters and such. This controller has methods for each of the routes created earlier. The index method retrieves all posts from the database and puts them into the posts instance variable, the @ sign indicates an instance variable. The show method finds just one post from the database based on the ID specified in the URL and puts that into the post instance variable. Notice that we didn't render a view manually in either of these methods. Rails does that for us. We'll look at just the index route for now. Here's a view written in the template language embedded Ruby, which is basically just HTML with the ability to embed Ruby code using those % tags. The first item in the template is a simple posts header, but over the rest of the lines we've embedded a Ruby loop to create links to each post. This template automatically has access to the instance variables set in our controller, so it can use the posts that we retrieved from the database by the controller's index method. Rails even gives us a link to method where it can refer to the routing table to generate a link to the page for a database object like a post. Here's what the route rendered might look like. So, with very little code overall, we've just added some pages to a web app. Rails used Ruby's features to provide us with lovely interfaces for each of our tasks, mainly the routing table here, but this extends into other areas of Rails we haven't touched on, such as database management. Web frameworks in other languages have taken inspiration from Rails, but I don't personally believe that many other languages lend themselves to these high-level interfaces quite as easily as Ruby does. In conclusion, Ruby lets you write terrible code. A lot of it absolutely should not be written, but it's worryingly simple to do it when you have the tools that are so easily in reach. But you have to consider, is that a bad thing? If you're a huge organisation writing code bases that will be maintained for decades, then yeah, probably it isn't what you want. But if you're messing around creating a hackathon or hobby project, then by all means go for it. There aren't many other languages where I have as much fun writing code as Ruby, and I found that sometimes I just wish I could do the same cursed things in other languages too. If writing absurd code which generates methods on itself or alters the behaviour of the surrounding language sounds fun to you, then have a look at Ruby. You might just find it as much fun as I do. If you're watching this live, then head over to Discord using the link in the description, and if you have any questions, I'd be delighted to answer them. Thank you very much for listening.